here. You can check it out. Lots of topics here.
Yes. You can speak it loudly.
Low in the ignition. So we have a lot of topics in the past, but we're trying to do more topics upcoming months. So you can check it out. Visit this meetup and sign up yourself. I'm also going to present this. Don't hear me?
No.
Well, it's just because you had your head facing that direction.
Oh, okay. So, okay, I'm going to pick it after that. But yeah, for now, I'll speak up. Yeah. So here is the Azure Cosmos DB that I'm giving the training. If you visit the URL, I will put them in the chat, the comment box, so you can visit. There's lots of training and the certification programs. So one of the certification programs that I'm also delivering for Microsoft. So you can check it out. With that, I'm going to start my presentation. Okay. So today's topic, we're going to talk about the Azure Private Link. Any of you use the Azure Private Link? No?
Yes.
You do?
Yeah.
Oh, you do?
That's
No? Oh, good. So use the Private Link. Okay. So that's the topic that we can talk today. This is a little bit about me, and I'm Udai for Ramachandran. Shortly call me Udai. So I work for a company called Acumen as a CTO. I'm also responsible for security, privacy, and compliances that I will talk to you briefly. I'm on Microsoft Azure MVP as of January 2022, and I've been working in the cloud for about 10 plus years, focused on all three cloud. Mostly focused on the Microsoft, but I have pretty good experience on other two cloud. We build a lot of SaaS product, which runs in a multi-cloud environment. I also run the user group, Nashua user group, which is primarily focused on the cloud and .NET, and that's my personal page, udai.io. We can talk about a little bit about virtual network basics. We are not going to spend all the time on understanding the virtual network, but this topic needs some basic understanding of virtual network. So we can assume that we all know. And then we're going to dive into a private endpoint. Then we can talk about the private link and then private link services and some of the use case scenario, some diagrams, how we can use it. And then I'll bring a real scenario, real world scenario that I've been using with my customers. Then we will do some demo of those. So this is the virtual network basics. We all know virtual networks. The basic includes of virtual networks, creating the network, and then if you get a network, you need a subnet. So you can define one or more subnets. Then you need a NIC, network interface. Then you need a network security group. How you want to flow your traffic. Then you will have NAT and source NAT, and then you will have a load balancer. Then you have an express route if you want to connect back to your on-prem service, right? So those are the basics of the virtual network. Everything is a pretty big topic, but we're going to assume at a high level we know these topics, right? So now we will dive into a service endpoint. To enable a service endpoint, we need a virtual network. Right? So if you create any services, it can be a platform as a service like Azure Storage or Cosmos DB or Azure Web Apps. You name it, any service that runs on the platform as a service. By default, when you create, it's public exposed, right? So you control that access by using the virtual network. If you configure, okay, it is not public endpoint, I'm going to enable this to the particular virtual network. So any service or virtual machines that configured or belongs to that virtual network can only access, right? So service endpoint is nothing but you making that as a private in a Microsoft network, but still your platform as a services are public. So you create a storage account, it's still going to have a public endpoint. You have a Cosmos DB, still going to have a public endpoint. They are exposed to the public. Someone knows the URL, they can try to get it, but they may not gain the access, but they can still see that this is a public endpoint. Service endpoint, secures that by using the virtual network. So only this virtual network can connect to it or see it, or this is the NSG rules can connect to it. Right? So those kind of security that service endpoint enables. Is also important to understand if you have a web app that's running in non-service endpoints, you will also get the outbound because on issues. So there is a 150 outbound connection you can go from any web app instance. But if you don't have that virtual network enabled on a service endpoint, you hit that threshold so fast. And then your application try to look so a lot of people realizing, not realizing, right? So that 150 will hit very fast. Say, for example, you request a page, the page makes the like a 10 connection to Cosmos DB, 5 connection to Redis cache, another 5 connection to storage. Now that one page is now enabled 20 outbound. Right? So if we have like a 20 requests coming in, 400 outbound connections. Now only 150 connections at a time is allowed. Everything else is queued. To resolve the problem, it is always recommended to go through the private network endpoints enabled, so you don't have the limit, right? But still, you will get into some sort of limit of memory or CPU, but at least it solves that outbound issues. It also secures your service to be private, but still those platform as a services like storage, Cosmos, web app, they are exposed to the internet, but you control the access. And that's where the private endpoints come in. Right? So the private endpoints, you bring the services into a private IP. So now you create a storage. If you create a storage account, you look for the NS lookup of the storage account. It's always going to have a public IP. But once you enable the private endpoint, that storage account now will have the private IP. So if your private, a CIDR range, you say 10.0 dot whatever the range you assign, is going to be one of the IP within the service. Right, so you bring any services. It used to be like few services 2 years ago, but if you look at it now, almost all the services you can enable the private. So you bring all the platforms as a service into private. But you can gain that access into you can bring a lot of hybrid scenario like connecting to on-premises using the express route, or you can use the MS Express, and then you can bring the private express route also, right? So, and it is also a single direction, meaning that you only go from a one direction architecture. So you have a platform as a services on a certain network. You have another network that trying to connect using the private endpoints, but it is just a one direction, not the reverse is going to invoke the other side of the endpoint. You can have multiple private endpoints created using the private link resource, and we will see it in a demo. When you see it in a demo, it definitely makes sense. It can use the same or different subnets, or you can use the same or different virtual networks. You can expose this into another virtual networks and another regions. You can also expose this into another subscription. So that's the concept of these private endpoints. Now coming to a private link. So if you look at the service endpoint, the service endpoint brings the same exact thing, but the services are public. But the private endpoint brings all the services into private. The private link, what it does is enables the platform to communicate to the services that are hosted in the private. You have 3 concepts here: service endpoint, which is you securing your platform as a services to connect securely using the virtual network or configured IP address, but the services are exposed to the public. Private endpoint makes all the services to have private IP address, not a public IP address, but you will have the DNS. But those DNS is not exposed to the public. They are assigned to a private IP address. In order to expose to the public, you need a public IP address, right? But in this case, they don't assign the public IP address. They only assign the private IP address. What private link does is it runs on the private endpoints, but it enables the platform that you can communicate to the services that are hosted using the private endpoints. Got it? So that's the concept. But now this private link can connect to the private services privately hosted to on-premises or to another network or to another subscription. So if Jay has another subscription that running on his machine, I have 2 services that running as a private endpoint in my subscription. I can create a private link service and give it to him. He can still communicate to my service secure because my service is running in private. His service is running in private, but now we provide a link exposed to him, and then I upload that link, and now he can connect to my private service over the Microsoft. Not going to go to the public. The cool thing about Microsoft network is very fast. So key benefits are, there is a 2 concept here. The private link is a platform that uses the private endpoint. there is another concept called consumer. Consumer is nothing but who is consuming that private links, right? So as it is the provider, if we create a private link, then we are the consumer. If I am creating a private link as a service and giving to somebody else, and those guys are the consumer, but I'm the provider. Okay, so that's the concept. Consumer privately connect to a service by using the private endpoint. Provider render the service, you know, by using the private link or private link. So when I create a private link, Microsoft is my provider. I'm the consumer. When I give all the services that run behind the load balancer, I give it to somebody else, and I become a provider. Somebody else, consumer service becomes the consumer. Okay. So there are key benefits. Privately access services on the Azure platform. You can be exposed to the on-premise network, connect data leakage, right? So this is very important. Data leakage is very important. So if you are not protecting those services private, now I can go to my home network and I can browse to the service and trying to export the data. Right? By making that as a private, but nobody can access the data outside of my network. Now I have more control who is accessing the data. So once I bring everything into a private, now I have to, nobody can access to it. I'm not going to add that IP address, but everything is a private. But what we do in a secure networks, we bring everything to private in order to access the data. Some reason you want to query it, we provide them another virtual machine console. So they have to get in that console by using the PaaS script. They can do a lot of copy paste, get in their virtual machine, and then they access it. Now, if this gives them more control, nobody can connect using the connection scheme from outside of the network. But they have to come into a network, they have to get into the virtual machine, then they need to connect to the data source. But now we have a lot more control over them. So when we have a compliance requirement like a SOC or PCS, those compliances, it is very important that the data is not exfiltrated. Nobody is seeing the data, they are copying it, taking it home. Right? These things provide the extreme security of your data. Very simple to set up, global reach. Extend your own services. If I have my services, I want to expose via private IP. Yes, I can do that. That's what the private link services we can see. It uses the approval. Every time you create a private link, somebody needs to approve. That approve by default. If you have a full configured rights, it's going to approve it by default. Or you have RBAC enabled, it's going to approve it. If not, then it will always come back to the next owner to approve it. They are not self-approved, but based on your RBAC role, as you create, it's kind of approved or waiting for them. So here is the private link workflow. So if you look at this diagram, there is a two-way you can make the workflow working for you. One is the manual, other one is the automatic. So I'm the owner of my subscription, so it's going to approve it for me automatically. But if I have someone delegate as a different role, then they will create the link. Then I will have to go and approve it. So if you look at this case, consumer is, I'm going to assume that my subscription is a consumer, me as a consumer, as a platform, as a service is a provider, right? So say these are the provider, for example, Cosmos DB, storage, or anything, Redis cache, or you name it. So now you create a private endpoint, right? And once you create the private endpoint, it's going to send to the request to approve or reject. As I said before, and I belongs to the owner role, it's always going to approve it. Otherwise, it's going to put them in a queue for someone to approve or reject. So, you approve it, then or reject it based on the decision. It's sending back to the client. Okay, it's approved or rejected. Then the private link services. That's how the private link works. Now the private link service is coming. So private link services, you package your private link that using the load balancer. So you can bring the load balancer that can be using the public front-end IP or a private front-end IP. When you say private front-end IP, you have a website running behind the internal load balancer. So you're always going to have a private IP because you don't want to expose that to the public cloud. Now you want to package that as a solution and sell it to somebody else. Now private link service is the platform that enables. You create a private link service, and then it gives the ID of the private link service. And the other person, another subscription, not necessary to be the same subscription. Another person, another subscription, they create the private link endpoint again, and then they use the ID that you passed. Once they put the ID passed in, then it knows what the ID is. You can manipulate that ID. It's auto-created ID. And it's going to send a request for the provider to approve or reject. So once you approve, they will be able to communicate back to your internal services that packaged part of the private link services. Okay. So if you look at the private link service workflow over here, so you can enable that back to on-prem services by using the express route. It can be in a MS Express, and then you can use a private express route for the faster network. And you create all those things over there, right? So if you look at it on the left-hand side, we have the so subnet. So we have that services created over there, right? Now the provider says take the provider network on the right-hand side. So provider network, they create all those things, and then they exposed it over here. They're going to create that endpoint using the private link services. How they can securely communicate, right? So the right-hand side is the provider who created that endpoints running. A lot of services running behind that endpoint. They exposed to the public IP as internal front-end IP as 192.168. Now they can able to communicate to that IP address using the private link. When you create the private link service, it also assigns a NAT. That NAT can be a static IP address, whether you can fix it, or it can be dynamic. It can assign one form. That's a high level. So you create, the provider creates all the services. I have an endpoint that I am running behind my service. I create a private link services. Then I give it to a consumer. The consumer imports it, and then the approval chain triggers in. Once the approval chain is approved, then they can work on it. And they can also connect back to their on-prem services because they have a express route gateway over here. So this is how you bring your on-prem, your consumer services in the cloud, and then your provider services. Now, how the private link services workflow works, I think we already talked about it, but say I'm the provider, right? So I create a virtual machine, and then that virtual machine, it can be a virtual machines, or it can be a virtual machine scales, right? So, and then it has to be part of the load balance. That load balancer can again be internal or public IP. And it also can use a basic or standard, but in this case, the IP address that you assign has to follow the standard IP, right? Once you create that SLB, and then you create an alias. So once you create the link service, it's going to give you the ID. And then the other side, the consumer is going to take that ID. You give into the ID to the consumer. The consumer is going to take the ID, creates the endpoint, he puts it over there. Then you will get a reject, request that you want to approve or decline. Once you approve the request, then they should be able to consume the connection. Okay. So here is some use case. Any questions so far? There is three concepts you have to understand: service endpoint, private link, and private link services is composed of those. The key difference is service endpoint is a public services. The platform as a service are public. You can control the access through the network, the virtual networks, or some restricted IPs. Private endpoint is everything is private. Now you securely access into the private service by using the private link. Once you have the private link, you want to expose the private link into a market, then you create the private links. Those are the four concepts. Let's look at the use case, how it works. So in this case, very simple use case, virtual network workloads with a custom DNS server, right? So you have the VM over here. So if you look at how this flow works, the VM, you have a connection string. You are talking to a SQL Azure database called AC SQL1 database Windows.net. That is your public DNS, but that's hosted in a private IP in this case. They are not going to be assigned a public IP, right? So since it's a private DNS, it also assigns the private DNS. You are going to use the connection string ACSQL1 database.windows.net. But the Microsoft resolves that and push into their backline, and then resolves, okay, this is pointing to the private network, and then sending back to the other side. It is the request.
So do you have to set up all the DNS entries?
No, you don't have to. You can set it up, but they you have to create it first. But the names you can pick it up, or they can auto assign. Yeah, I'll show you the demo. So it responds and it talks to the this is the Azure DNS IP address 168.190.129.16. You see it on all the diagrams that we have it. So here is the VM. That VM is going to talk to the SQL service, right? So you have the connection string AC SQL1 database Windows.net. So if the request goes in, look at it as a DNS. Now it comes back, okay, I got it, that result as a private link.database.windows.net. Right? Now it's come back, okay, there is a private link, and then it results that IP address 10.5.0.5. That's how it communicates. So you send a packet to AZ SQL database.windows.net, and then it gets into a Microsoft backbone network, and it resolves what it is, and then it knows that it's pointing to 10.0.5.0.5, and then it puts back onto it. Then the network goes back, right? That's how it works.
So a question on that one, Udai. So for that configuration to all work, that means they're wrapping this. So you have the VNet consumer 01.
Yeah.
So you have the VNet, and then you've had to connect the SQL Server into the VNet. So that means that in order to get to the SQL Server, you have to connect to the VNet to communicate to it.
It's all in part of the VNet.
Yeah, so there's no way to get to that SQL Server without going to a jump machine or a VPN.
It's because it's a private. So you have to have the service that connecting to the SQL part of that VNet.
Yeah.
Or if it's a different VNet, then you have to make the peering.
Got it.
Okay, so if you don't peering it, then you have VNet 1, the service exists. You have VNet 2, which is a different side array.
Right.
If you want to expose the service to that another VNet, then you have to make the peering one.
Got it.
And then you also have to enable on the private link. I'll show you in a demo. On the private link, I'm going to expose this into that VNet. So if you have like a 10 VNet running in 10 different regions, you will have to expose this private link into all 10 VNets.
Yeah.
Then only it can connect.
Okay, cool.
So now it's another example over here, custom DNS server. So if you look at it, there is a 2 regions over here, right? So VNet 1, that's whatever we were just talking. You have VNet 1 on the 1 region, VNet 2 on the 2 regions. How they know that there is a SQL Azure, sitting in another region or common region or one of those 2 regions, right? It's the same exact diagram. When this goes through region 1, it resolves the same exact way. So I'm finding it, you giving the DNS public DNS name, it resolves to the private DNS, then it resolves to the private IP. Okay, then it communicates back. Same exact thing happening on the other side. It resolves the public DNS with private DNS, and then it gives the private IP to communicate. But if you look at it over here, there is a VNet peering, right? So this SQL as it's sitting on a VNet over here on a different subnet. But here is another VNet on the on a 10.10.0. Here is the VNet on the 10.20.0. But SQL Azure is sitting on a 10.5.0. So those 3 sitting on a 3 different.
Did you need to go out?
No, they said we don't need to. They're just testing it to see.
Oh.
So now you have three VNets over here, but as I explained before, you have to enable that peering so that it knows, okay, there is a service standard. So here is a third example, how you can talk to on-premises network, right, without a custom DNS forward, like a dedicated DNS forwarder. So if you look at it over here, the number 1 in link is from going from the on-premises machine. Okay, look for the DNS forwarder. Okay, I need a connection to AZ SQL database Windows.net. It's going to look up the DNS, Azure DNS lookup, as I said, all the diagram will have that. Then it's going to resolve to the private link. Then it's going to resolve to the IP address of it, and then returning back to that machine. Then it uses the express route to communicate back to that private link, right? So then it putting back into the Microsoft. Now the same thing, same exact thing, but now you have the internal DNS server, right? So the previous diagram, it did not have an internal DNS server, but now you have the internal DNS. So now your virtual machine is going to go back to the internal DNS server, then resumes the same exact. So internal DNS server is going to talk back to the internal DNS forwarder. It resolves that, okay, where it is, and then come back over here. Then it uses the express route, okay, connect to the private link, and the private link connect. Now here's scenario 5. The difference is a spoke model, right? So if you have the private network, on-prem network over here, then it goes to the DNS forwarder, resolves everything. But if you look at it over here, there is a client to spoke. So the one goes to the DNS forwarder, and also Let's go to the client bespoke model here too. So this is the 10.0.0, 10.5.0 over here, but we have the peering enabled over there, right? So there's another VM that's sitting on the somewhere in the cloud. Okay. So what they're explaining is your on-premise connection, how it works, but in the same exact connection, how it consumed from the cloud as. So this one is coming from the cloud, this one is coming from the on-prem, but the flow is remained same. When it comes to the cloud, it's going to go back to the DNS forward or resolve and then give me what it is, then I'm going to connect back to the SQL as. And when you go from on-premises, is go back DNS forward and give me, give me that address, then it's going to use the express route to communicate back to this. So how do you verify the private link? Are you really enabled, right? So you're going to type, every service has the public DNS, right? So you're going to say NS lookup that service name. It will never give you the private public IP. It's going to give you the private. Once you see that private IP address means it's a private, it's not export to the public internet. You have to have that feature network and everything created properly to communicate. You can also use the name resolver, or you can use the TCP ping, so that it will show you how you see the public IP address, then you are not configured correctly or something. If you see the private IP address, yes, then you configure it. So here is the demo scenario that I'm going to walk you through today. So if you take this scenario, we have two regions, region A and region B, right? I call it as East and West. For the region A, I call it as a primary region, and I also call it as a data residency because that's where all my data is. And then data region B, I call it as the geo, which is mainly for the high availability and the traffic receiver from the closest to proximity. But I also have a services running over there. It's optional. We may have a storage account, but in this case, we're going to have the storage account on Reddish Cache and Key1, but all the other services are optional. But this is one scenario that we can for the high availability, right? So if you look at it, how these two knows how to communicate, you have to create a private link. You have to enable the peering. So if you do all those things, you expose you enable the peering, and then you expose the private link on both network. Then the both network can see each other. They can start communicating to the services. So region B can connect to region A services, vice versa. Region A can connect to region on a failover stack, on a real Otherwise, they can talk to their own services. Region B talks to services. All right, let's look at some demo. That's a problem. I want to do. I'm going to share it.
Yeah, I've seen the room. Seen my bald head in the video.
So see it.
Yep.
All right.
Yes.
So I have a resource group here. I think I can walk you through all the VNet creation, but if I walk through everything that I created here, it will take approximately 2 minutes. So I spent some time I created everything. But as I said before, we would assume that we have some knowledge of it and creating VNets and all this, right? The first thing what you do, you create a virtual network. I'm not going to complete it, but I'll walk through a few steps over. So I go through these steps, and then I pick the subscription, whatever region you want, and say the name, the region, and then you're going to set up the CIDR range. So if you say 10 dot, I already took the 2, 3, and everything, so you can say 10 dot, 4 dot, 0 dot, whatever was there, and then you pick the 16, which is 255 and the 255 range. Then you define a subnet. In this case, you're going to define a more. In our example today, we defined a multiple subnets. One subnet for the database, like a data, other subnet for the virtual machine where we want to see what is going on, so nobody can access out. So we do need to access some point inside. So we have the virtual machine in our own subnet, and then we have all the websites posting on another subnet. So subnet 3. Then we created 2 subnets for the function app and then the web app to communicate as outbound. We also need outbound connection so that if the function app trying to outbound to any of your dealing services, they can outbound connection. Then they can, you do have to create a subnet. So you create a subnet, just click on it, give the name on it, and then you subnet web, for example, right? So and then you pick the range. So just going to 10.0.4 over here. So I say 10.4. I start 1.0 is 4. It's going to give me a 255 address of this, right? So which 5 of them are reserved and 251. Okay. So 24 is the last one. He said 32 is fully done, and 16 is you get a 255 up here and then 255 up here. Any address you get it, you go 8, then you get a 255 up here, 255 up here, and then the multiply 255. Okay. But in this case, no, we create the one subnet for web, add it, and then you keep adding whatever subnet you want. Say subnet for data. Define it. You got it, right? So
What's the service endpoint at the bottom of that? Do you use that after the fact?
where do you see that on the subnet?
Yeah.
Oh yeah, we do use after the fact. So when you create a subnet, you tell them what for you creating this. Okay. Option A, you can select the subnet over here. Say for example, I create a subnet called data, SNet-data, right? I can say I'm going to use data for the storage, keyword-based, keyword also data. I'm going to select the Cosmos DB because I know that's not it. And then the search. In our example, we have all those things. So you get the point. But either you can assign it here or you can assign it in the services. You could have services, enable private link, assign it. But we are not going to complete, so it doesn't matter. And then go to the security. You can do TDS protection or firewall and tag and then redo. Okay, so that's how I create the virtual network. So I'm going back to my already created virtual networks. So if I look back to my virtual network over here. Yeah. So I have 2 virtual networks. One is the VNet, Private Link demo, EUS stands for East US. And then I have another VNet demo, WUS stands for West US, right? So if you look at my East US over here, so if I look at my subnets, so I have this kind of subnet. So my address beginning with the 2.2, 10.2, right? And then I have 1, 2, 3, 4, 5. So look at it, I named it, one for data, one for web, one for web out, other one for function app I want out. So whenever you bring those web app, function app, you need out too, because they are bidirectional, right? So and then the SNet for a VM where I have some virtual machines, so we can see whether we are able to connect. The same exact setup that we did for the West US. Okay. So if I look at the subnets, I have just parallel, right? So whatever I create in the East, I created it. But in this case, the range is 10.2 because you can use that. You have to use another CABR range. But it can be anything, 10.100 or 192.168, whatever. Okay, so that's the virtual network. So these are the virtual network, these are the subnets, right? Now let's look at the how we enable the service endpoints. Then we will talk about the private endpoint. So I'm going to pick up the service, maybe a storage account over here. So let's take this sort of storage. When I enable a service endpoint, I go back to my networking. If I say disable, right? I'm disabling. Completely private, I'm disabling. So if I go back to my private endpoints, I have created a 3 private endpoints. Okay? But in the service endpoints, I shouldn't be having these private endpoints. I remove all the private endpoints. My storage account will still have public IP. But in this case, I added a private endpoints. Now it's all gone to the private. But the storage account provides the multiple services, right? It provides the block, it provides the table, it provides the queue, it provides the files, and so on, right? So if you want, they are different endpoints. They are not the same endpoint. Take a SQL Azure, it's the same endpoint. SQL Azure.windows.net. If you take a Cosmos, whatever the Cosmos name, Cosmos.windows.net. But when you go to the storage account, it has the block.windows.net, table.windows.net, queue.windows.net. So you will have to repeat that creation for every service. So in this case, if you look at it, I get a private endpoint for the block. So look at it over here, right? So let's enable private endpoint. Let's go back to this service. I click on the network. Right? So if you look at it, it's all network. If you do this one, enable from the selected virtual network and the IP address, then you are configuring the service. Okay. That's the service. If you do this, now you're completely removing that. Now you are one step before you go into private endpoint, right? So that's how you do a private endpoint. Let's go back to this service. If I go check this namespace over. Walk through one services, then all the services works the same. So this runs on these address, right? So that's a public address, right? So that is not a private address, it's a public IP address, that's how it runs. So now we go back to the networking and we create the, we will disable it. We will have to disable it in order to get into private network. So we disable it. Personally, I can disable it here entirely because this service is going to different application. I'm going to demo you. So I'll go back to the other service and browse the same service. Then once you disable it, you have an option to create a private network. So you go back to the private endpoint connection, but you can create. I already created for those 3 services. If you want to create more, then you can create. So I'm going to put some name over here, private link, and I'm going to say files dash. Other than name, we are not going to complete, but slash files. Same thing, use viewers too. You can have that link running in any. That's not necessarily very useful. Because when you're going to communicate with the other network, you're going to enable that link. So that's a platform, right? So if you look at it over here, I'm going to select the file service, right? And then I go back to the next tab. Now I pick the virtual network. It's going to give me the virtual network based on the region that I selected. So in this region, this is the virtual network. I'm going to show me the subnets, and then the subnet I'm going to select the data. So I'm going to aggregate all the data services in the data service. Okay. If you have an application security group, how it's flowing to a virtual machine applications, and you can do that, but this is a different concept. We are not going to talk about it today. And then it comes back to the DNS, right? So this is where it creates that you ask me a question, do we need to configure that? So it gives the DNS over. Okay, that creates a new DNS. So here is the thing that I want you to understand. Once you create on one region, it's going to do the right private link.file.co, right? Private link. If you do a blob, it's going to private link.blob.co. But if you go to another region, what will happen? You're going to have a conflict, right? So yeah. So when I was doing this very first time last year, around the same time, it was an error. So you have to go manually delete it and re-add it to the same. Because you say something overlapped or conflict. But if you do it today, it's not going to conflict. It knows. It just creates a private DNS in both regions. Okay. So you're not going to complete it, and then you go to a tag and then review and then create it. Good. So that's how you create the private private endpoints for any given service. So once you click on the private endpoint, the few things to understand here is the DNS configuration. So if you look at the DNS configuration, this is your DNS, right? But when you're going to communicate, you are not going to say your connection string is not going to have a private link, because it knows that the connection string is going to be that runs on the IP address 10.2.2.4. This is your network interface. It creates it automatically. If you look at it, again, it gives you the IP address, the IP configuration, the network security group, how it's configured. There is no security group configured because it's a private service. But if you have, if you want to add some services to be configured, then you can do that. Look at the DNS server. I just looked at it. It's inherit from the virtual network. That's what is DNS. So let's go back to the services here. Right, so this is our service, right? So lab.windows.4 thing. So let's go back to this service. STPL. So this resolves the address, but I'm not sure why it's giving this address. But if you look at the difference, this resolves to, okay. I look at the one public. The other service was private. Any questions so far? Okay, that's the right one. So this resolving to aliases of that alias, and it's pointing to the public IP address, right? But I'm not sure why this is. If you look at it over here, this has two aliases. I'm not sure why it's showing there, but we will get into the virtual machine. That's the private, and the VNet. Who will see it exactly what the IP address is. I was slightly confused why it's showing the word. All right, let's go back. So we configured that storage account. That's the same way we configure any service that we want. So let's pick up another service called a Cosmos DB. For example, go back to the Cosmos DB. You click on the firewall and virtual network. You do a selected network, the first thing, because you can do all networks, right? And then you go to the private endpoint connections, and then you create a private endpoint. So this is the question of when you're creating the services, there was service name. So if you follow this blade, the very next screen will be, for example, I'm going to say something and go next to the source. This was 2. And then here that I have to select the resource type. So I have to select the Cosmos. Okay, that's the resource that we were selecting. So you enable the private links. That go back to the private endpoints, and right. So private endpoint, add the private endpoint. Again, as I said before, private link is in the platform that uses the private endpoint. So in order to secure, we have to enable the private endpoints. Same way you go, and I will show you where exactly you would enable these direct sense of the platform. If you go back to the storage, not storage, maybe a search index, just an example. Go back to my search index over here. Again, the same concept. You go to networking. Now you disable the public access first, and then you go back to the private access, and then you add a point, right? So if you look at it, it will tell you which network it's running. Right, so it's IP address standard 2.7, which is using the private endpoint. So here it is, right? So it is using the attended 2. Whatever name I gave it, and then it adds the private link, and then it runs over. Okay. Now let's go back to web app or function app. So now we have the web app that running on the private network. We have function app that running on the private network. They're all going to communicate these services. And one of the service that I run is also belongs to another network that runs on the west region. So if I look at it over here, this storage account, I go back to my network. If you look at it, I completely disabled it, but when I have the private network, yeah, so I have the approved network. If I look at it, that has a different IP. Right? So this is going to have that's the difference. Constellation. It runs on the 10.3.2.4. Okay, so all those things runs on the 10.2.4. I also have two virtual machines, one on the east running on the east virtual network, other one on the west running on the west virtual. Before we dive into browsing that, let me show you one other thing. So we'll look at it on the function app. Okay, let's take this one, right? The function app. So there is a requirement here. If you want a function app to be a private endpoint support, it cannot be a consumption. It has to be a premium thing. So that's the catch. Consumption plan, you use it, you pay only when you use it, and then it scales, you pay for it, right? For premium plan, you will have to pay at least one instance constant. But then it will scale out. Like, as you scale out, you pay for it, but at least one instance will be running on. To pay whatever that size will be, one instance in Java. This private endpoint you can only enable on premium tiers, not on premium. That's a one thing. So if you go back to the headphone, right? I enabled on the private endpoint. I also enabled on the VNet integration. So if you look at the VNet integration, it uses that 10.2 because it runs on the east VNet. Okay. It runs on the subnet function use out. But while creating it, will ask you what outbound subnet, what is the inbound subnet, and everything. So you will have to say, because it's an app where it's going to communicate for the outbound, how it's going to take the inbound, everything it asks. What I did here, I put this function app behind the network, so it only runs and it takes all the data, all the bindings from the services that are running within the network, are the network that it's peering. So we enable the private endpoint, we enable the VNet integration.
So if you did that same setup on a web app, then the web app's not visible to public network.
You have to use, okay, good question. You set up the same thing on the web app. The web app is not public, but you are not going to disable it from the public. Also, okay, cool. But if you use the latest friend door premium tier, you can put all your web app in the private. Premium tier let you connect privately to your web app. It can now route to your privately hosted web app. So you cannot directly access the web app, but now you can go through the front door.
Yeah. That's
right?
what I was thinking. You need something else in front of it.
Something else in front of it in order to hit the website. Either if you don't use the front door, you disable that. You leave that web app only in the VNet. At that point, even is a service endpoint. So your web app cannot be the private endpoint. Your web app can be a service endpoint. And because all the other services belongs to the same service virtual network, and if you have a services running on another virtual network, you already peering enabled, so it can now talk to all this. But once you enable the private endpoint to a web app, now that web app cannot be exposed to the outside. To do that, you have to go to the premium front door services, and there they support the backend pool services part of the private endpoints. Instead of service endpoint, now you select the private endpoints. Now they can communicate back to those things. Okay. So if you take a web app, in this demo I disabled it, but we can also enable it. So if you look, I look back here. So we have the private endpoint. I need to turn it off. Once I turn it off, this will become a service. But you still have to put them in VNet integration so that it can reach out all the services. That makes sense. So that's running over here. So now let's go back, and then one other thing that I forgot to show you. So if you go back to the VNet over here, look at the hearing. So you can see that I'm talking to W. This network is talking to a peer West US. Right? They go back to the West US network, try to appear, and this is being the East US. That's how those two networks can communicate to each.
And the IP address can't overlap, right?
They cannot overlap. You won't be able to create it from the same subscription.
Okay.
Because as you create it, it's going to tell you overlap. Without assigning a new yeah, non-overlap. So okay, so that is done. Now let's go back to services. We have a lot of services running on the private endpoint. Let's try to browse one of the services. Right? So if I go back to say storage account, for example. I mean, you see a lot of links over here. They are created as you create a private link. We go back to this service over here, EUS. I try to browse this endpoint. Top containments. Taking cloud. I don't have access to it. Yeah, I can access it. The same thing happens with the Cosmos DB, for example. Any services. In this case, I put all the services into a private endpoint. Go back to the Data Explorer. Come until the Data Explorer. After that, it will tell you containers. Say I look up this container over here. I won't see anything. So I won't see any data. Right? But I do have access. That's how it is. I guess you can see it's a little more details. In the bottom, you can see it. Either you requested that IP address to access it, or block it, completely block. So it runs on the file. Now, if you are running a secure website, everything is set private, which is great, but you do need some time to access the data. But you don't want to give that access to my public IP address. You want to control it within certain IP address. In my case, is what we do. We control everything to go through a one virtual machine. So what people do is that is enabled by JIT, just-in-time access. Whenever people want to connect, they will have to request. Now we know who is going to get into that. Right? So first level audit is done. Once they get into the VM, there is a diagnostic audit. You can enable on all the services. Now you know who is accessing what. Right? So you have full control. If somebody trying to run a query, copy the data, you know they are trying to run a query, copy the data. So you need to secure the data if you really want to be meet the compliances. So now let's remote into VM. VM over here. Let's go real demo. Yes. I'm still able to connect this VM because this VM only enabled the service endpoint. I did not enable the private endpoint.
So you don't have to connect to VPN to get to it?
If I do a private endpoint, then I have to. Yeah. But I only enable the service endpoint.
Got it. That's cool. That's useful.
Yeah. Because I need something to get into that.
Right.
I don't want, I don't want.
This is like a jump host.
Yeah,
You hop onto
exactly,
the jump
exactly.
host, and then from there you can connect to that private endpoint.
Yeah.
But then you have to whitelist that jump host IP address.
Yeah, if you want more, further, yes, you can.
Yeah, because otherwise, how it would know that this is the good jump host for you?
No, because it's part of the.
A part of the same version.
same
Okay.
service.
Got it. I like that. That's nice.
So this is what we do. If you want, this also meets the compliance. People are working from everywhere in the world, right?
Right,
You
right.
probably work from there.
Yeah.
But there is a compliance requirement. You can access the data when you are in different regions.
Right.
Okay, now you want to give access to that person. How you give the access to the person? So you have the host running in a US, let them connect to this machine, and they can access the data from this machine. So if you look at the audit log is going to say wherever this VM is, that's where the access happens.
Yeah.
This access never happened outside of the. So there is a lot of compliances required. So you will have to follow all those. So if I look at it, I installed the Azure Storage Explorer. So if I look at the AK Cloud here, that's my container. But now I am able to see the data, right? So this is the same container I was not able to do outside, right? So I have some data, I added something. Right? So now how this overall functionality wise work? I put a very little demo here. I have a function app working on the East network, which is this. As soon as I file a copy over here, my function app will pick it up the data and move it to the West network, which is also a private, right? So I have two storage accounts. One runs on the East, the other one runs on the West. So whenever I copy files over here, there is a function app watching for the binding, and it takes that stream and then move it to the West network. So let's go back and add a small file. See, I can upload this file from outside. I have to come into the host. So I'm going to copy this file. We also do this for our product because we were trying to use the blob replica.
Yeah.
Replica takes a long time.
Yeah.
And then another problem is everything else there is only one write. The primary can be right. One region can be right. Every other regions can only be a read. That adds a latency when you're trying to connect, say, from India to a server that's located in the East, right? Adds a huge latency to jump back. So we will have to enable write on every region, throw metadata, and then they all emit some sort of events that I have files. Based on the metadata, we want to replicate the same file to there. So if the India region, for example, writing the file, right? The primary can be the viewers, but now it takes that file monitoring and then replicate back to all the services. But now every host is a write host. So from the metadata, it knows it no need to replicate back to the sender because there is some metadata tells it came from that region. So we skip that. So
Distributed processing.
yeah, distributed processing, because to do a highly scalable performance system, you have to run everything everywhere. We even run the search indexes everywhere. Because when the search index, they don't give you a multi-write. Right? They only can give you a fault tolerant or high availability in one region. That goes down, now you have a latency to replicate that back to other regions. That's one problem. Second problem is if you have a compute running in everywhere, your search index can only in one region. Now there is a latency attached. It has to come all the way from the traffic to reach this one search index. So what we do is we distribute. So we have a cluster running. As the data comes in, we use a Cosmos multi-write. After the data comes in, it runs the multiple search indexes on every region. So even if the one region gone, there is a duplicate search indexes on it. They'll pick it up. But that provides you low latency, high performance. And so the lot of problem that we face all the time is the performance. How we solve this one? We throw a lot of things around everywhere. In the Redis cache, we don't rely on the central cache. We don't rely on because the Microsoft provides a central cache. But all the other caches are read-only. But there is a transient error happening more frequent. But Microsoft says you need to handle the transient. That's impossible because I'm going to write into one region. There is a huge latency coming to write in a one region because there is only one primary, right? So everything else is a replica. But those replica on a high frequent mode, like a highly throttled mode, it's going to have a problem. More transit may take like 5 minutes to address the problems. Now we have a problem. So we change the design. We are not going to use that model because it's expensive too. We throw small caches everywhere. Now, if you we use a front door. Once you hit the front door, if it connects to the east, most likely you connect it to the east. Never going to come out of east until there is a significant disaster happens. So I connected to west, for example. I'm traveling to California. I'm connected to west. 99% of the time I'm connected to west because I'm there. Maybe I'm flying now, but 4 hours later, I may be connected to a different region. But when I'm actively working, I'm connected to that region. So why do I have to route back to the centralized cache? Why not I throw a small cache in every region? So we solve the problem, a lot of these little time problems by throwing distributed things everywhere. So this is the one example. So let me copy this file over here.
And it depends on everybody's scenario and requirements.
Exactly. But am I connected to the right? Close it. Yes, the monitor happens on this. I put on the wrong. Yeah, I put on the wrong. Monitor happens on the east. Yeah, new one. I go here. It's here. Yeah, that's the fast. If I use a blob replica, it will take 5 minutes. I don't have time to wait for 5 minutes. You can see it's instantly. So now my storage accounts are sitting in a private endpoint. My function app sitting in a private endpoint. My storage accounts are sitting in 2 different virtual networks. My function app sitting in a 1 virtual network. Now they were able to connect perfectly fine. Right? So that's the private thing. But now if you look at the services over here, so, let's look at NS lookup, this one. Now it tells you the IP address is right, but this is a DNS lookup service. Okay, so you were talking about the diagram. There is always a DNS lookup address. It went and looked at it. Okay, I see this, but that now pointing to 10.3.2.4, and this is here is the alias. So if you look at the east one, now that's other one is a 3. This one is a 10.2.2.4. So we kept the 2 is the data on both sides. So you see the J, and then we create the same sequence. So we assign the verified first IP address. But as you can see, this is running on the private IP. Right? So somebody trying to hit this, they never able to reach this. So now going back to the demo. So we talk about the web app, right? So here is the web app. Let's go browse this. Is forbidden. They can access to it because I put that web app into a private endpoint. So we'll go back to this machine over here, the machine from the west coast. Perfectly able to find it. But now I still want to use these services, but I don't want to be in a private network. I want to expose this endpoint to the public. That's where you're going to scale down to the service endpoint. So I go back over here. I click on the service. Networking. Then I turn off this.
So if I had two web apps, one web app is say the front end and another web app is really just APIs, could I put the API one in the
Yes.
private
Yeah.
and keep the other one? Okay.
Because your public one and the private one on the same network are in a different network tier.
Yeah,
So
yeah.
now they can communicate.
And then suppose your database is Azure SQL database. It has nothing to do to go on service endpoint or get exposed, right? Because it is going to be hit only by the application side. So you
Right.
expose your web app because that's where the clients are going to hit, and then you hit your.
Yeah, now I remove the private endpoint, brought on the service endpoint. Now I'm able to browse. But if you want to keep this entire your public endpoint website and then your API, everything behind the scene, then you have to use the front door premium. If you use a front door premium with ASC, not with the app, you have to use the app service environment. App service environment is slightly expensive than the normal web app. Then you can integrate the private endpoint to your front door. Okay, awesome. So that's how you use security. But that comes another problem because you frequently want to deploy it, then you have to go to the network and do all the deployment. That's a little pain. That's why we don't keep it that way. We are fine. But what we do is we expose that as a public still when we use the private front door, or we set the header. Only the front door can read. Front door requests are up. You do that by using the access restriction. You go to the access restriction. Go to you go to access restriction and then you add a rule saying that I'm going to allow only from the front door. So front door provides a host header. It is also provides a value and then you add it over here. That way, only the front door can route. Is still exposed to this to a public, or only the front door can front door request is not. Otherwise, you get a forward access. Okay. Now let's go back to private links. So you saw the service endpoint demo, you saw the private endpoint demo, you saw the private link demo. Now you can talk about the private link service, the last one, right? So if you look, now in order to create a private link service, you have to have a load balancer. That load balancer can be a internal load balancer or a public load balancer. Once you bring a load balancer, it only supports the virtual machine. Only that concept is how can be exposed. I'm not going to explain how to create those things. Instead, what we do, we will look at one of the load balancer. So if I look at this load balancer, now while creating the load balancer, create one, pick up the subscription, pick the resource to name, give the region, and then this SKU should be a standard. If it is basic, you are not you what the SKU should be a standard, but again, the code LB type can be a public or internal. In either case, you can create a PLL service. It can be a public PLL service or internal PLL service. And then the tier can be regional or global. Load balancing. So then you go back, you do internal, and the IP configuration is going to give you internal rules. If you do a public, and the IP is going to be a public, and you can browse out. You always give an internal because we are using the private link service to go private. So it's like the next one, and then you add the front-end IP configuration, you give some name, select the virtual network based on the region you selected. You can just give you that. Then you pick the subnets. You may see that out subnet is grayed out because when you create a function app out subnet, that's the only function app can cut. You cannot reuse that. You will have to create an outbound subnet for every service. That service is created. That's why it's grayed out. In this case, this now I'm going to this is what this is the load balancer. So I'm going to say web. Okay, so pick that one, and then I can assign this dynamic or static IP address. Based on static, it's going to put the fixed IP, the internal IP. In this case, right? So I say add. Then I go back to the backend. So I can fix the backend over here. It's complete it and into all the configuration, then you select the VM that runs behind it. Must have a standard SKU public ID. And so it a standard SKU. Okay.
Filtering on location, I believe. Click all, then.
Is it? Very good. Oh, please do. That's the only mission I have.
Oh, that's it. Okay, then looking in the same region.
Yeah, that's it.
Is there already, can you,
I already used the people. Yeah, it's kind of strange. But you get the concept. You add the machine or you add the scale set and then you complete it, right? So that's how you create the load balancer. Once you have the load balancer means, then you already put a VM that you can assume that you can't get a site. In this case, we are running a site, something like this, 10.2.3.5, we reload it, that things. That site is running on the VM. Now, how do you create a private link service? You go back to the private link service. Okay. Then you do a create. So I already created two, but you create a create, right? Then it's going to ask you this screens, give some names, go back to the outbound settings. Now you have to pick up the load balancer that is already selected. Example, when you select it, you have to create a new load balancer, but I have created one. But you get the concept. You complete this step, and then the access security, which is going to give you 3 steps. I just ask the steps. It's technically anonymous. Anybody can access with those who have the ID or what it is, or they are back. Okay. So once you complete, it's going to create a private link. So what it look like when it creates a private link. So for example, go back over here. This once you create it, this is what you see. The alias that you need is this one. You need to copy this one. You copy this one, and when you create the step also to tell you, do you want to allow any subscription? I can say all subscriptions, and anybody can see. So you can go and see this service. Or I can say approval required. Okay, so an approval required means if I give this ID to you, you go back to your own subscription. Say I'm going to switch to my other subscription over here. Go back over here, then I can say private endpoints, create. I'm not going to complete it as a second code. Let's do other. Okay. So okay. Now choose this to paste the ID. Okay. So that's how you complete it, and then you select the network. So it's available. Then you complete it. Created. We already completed. I have created 2 things. So I have a slight problem browsing there. I don't know what I missed it, but I have a support ticket. I need to solve. So I won't be able to show the demo of browsing the endpoint that runs on another subscription. Okay. This I was trying to browse this from this subscription over here, which is completely different identity, right? But some weird reasons on communicating. That's I need to work with support on this. Overall, that's the concept. Any questions so far?
no, that's good. I mean,
Great.
Yeah, this is all region 1, region 2, and then this will be the peering. There is a very nice video over here. The Ignite conference, 2.5 years old. I thought that was the first 2 videos.
Did we share this
Yes.
presentation slide?
Yeah, I have a lot of them.
This has been really helpful.
Was the topic that I. Everyone can download it. I will update them.
Okay.
Ask. So, any question, guys?
No, that's been,
Yeah, I've been using this. This is a critical point. We run a SaaS company, software as a service company.
Right,
We have to secure it
right. No, I
in
totally
order to
understand.
gain confidence from the customers.
Right.
And we also a technology company. For technology company, we work with the customers. We need to suggest to them the best enterprise architecture.
Right. And this is one of the really best layered approach from the security side. And then you should be able to produce evidence and then have like confidence that things are secure. At the same time, scalability, performance, all those things are ground zero reality, no matter what you have to face. I like it.
It's it's not hard. It's very easy. I'm trying to build a script for everything. So in a software as a service model, one time, right? You set it up, it is there. So I didn't automate it yet, but I have planned on.
nice. Very,
Thank you so much.
thank you so much, man. I will stop the recording.